We have 2 more examples left. So we are going to type this into our calculator, get our table pulled up. Just looking at this first off, we can see that our A is 3, our B is 1/2, and we don't have a K being added on, so K is equal to 0. Because our B is 1/2, this is going to be a decay. It's between 0 and 1, so it has to be a decay. And since we don't have a K being added on, our horizontal asymptote is y equals 0. You can also go ahead and note our domain is going to be all real numbers, which is true every time. And based off of that horizontal asymptote, our range is going to be y is greater than 0. So again, I'm going to type this into the calculator, get my table, and plot my points. With example 3, we are going to be typing in 3 parentheses. We're going to need to make a fraction, so alpha y equals, enter, 1/2 parentheses exponent of x. So your screen should look like my screen on your calculator. And again, we are going to graph this. If you notice, whenever the number inside a parentheses or the number with the exponent is a fraction, we are going to have decay because b has to be between 0 and 1. So a positive number, that's a fraction, that's why we call it fractional decay, is going to make that decay. And if b is a positive number larger than 1, then it will be a growth. So we have a decay here. I'm going to look at my table, second graph to look at the table. And I'm just going to enter these numbers that are on the screen from -3 to a +3. And that should fill my table. And then using those numbers, I'm going to graph it. All right, we have our table filled out. I can see that my y-intercept is at 0, 3. I'm going to plot my points. I have -1, 6, 0, 3, 1, and 1.5, 2 3/4 as we go down. So get very close, and then we can create our line. Looking at this, we can, of course, see our horizontal asymptote is that y-axis again, which is y equals 0. And there you have it. So we have a decay that also has an A of 3. It looks slightly different than the previous examples. And our next one is also going to be very different. This one actually has a K that is not 0. So moving on, we have example 4, which, our K is the number 3. So we have a K. So that means our asymptote is going to move to y equals 3 because it is y equals K. And our range will be y is greater than 3. Looking at the rest of our equation, we have an A that is 1 and B that is 2. Because B is greater than 1, we have a growth. And now I'm going to go to my calculator, type this in, get my table of values, and then graph it. Example 4 looks a little different as we have that addition. So when we type this into our calculator, we want to make sure we do that correctly. So we have 2 exponent x. And then I'm going to arrow to the right to get out of the exponent. I want to make sure my +3 does not go in with the x. It's going to go after +3. So your screen should look like my screen, 2 exponent of x plus 3. So now we can graph this and see what it looks like. And this looks a little different to our previous ones we've typed in. It looks like it has shifted. It has shifted up. So our horizontal asymptote is in a different place. It doesn't look like it's approaching the x-axis anymore. It looks like it's approaching a horizontal line just above it. So we'll need to determine what that horizontal asymptote is. So looking at our table, so second graph to go to our table, we're going to copy down some of these numbers. I would say we can arrow up a little, see what these negative numbers do. If you notice, the negative x values are all some decimal of 3, and we get closer and closer to just a whole 3, and the decimals get smaller and smaller and smaller, and then it just turns into 3. So that the value of 3 here for that y is not actually 3 because it gets really close to that line, but it's not supposed to actually cross it. It's just those decimals are so small, it's really hard to put them on the table. So we're really going to be concerned about, we'll say, -4 to 3. -4 to 3. So you're going to write down those values on your table, and then we will graph it and talk about the asymptote and what this does to the domain and range. I have my table of values copied down. We notice that our y-intercept is at 4. 2, 3, 4. And I'm going to plot these points. 2, 3, half. And then graph it. So this looks very different. Our horizontal asymptote is at 3. So it has shifted up a little bit. And so has our y-intercept. There we go. Sorry for the yawn. Oh, our domain, of course, is going to be all real numbers.